Excellent. Thanks, Runway. So I suspect the audience has a number of questions. So while you're thinking about those, I wanted to start off with a couple for the panel. So it sounds like we have a fair bit of consensus that freshwater sources, groundwater sources, or fresh groundwater sources are certainly being adversely affected into the future. But if we were to able to develop the treatment technologies and solve the logistical challenge of getting it to where we need to get it to, would it be fair to say that we could shift New Mexico from being a water poor state to a water rich state? So, Alex, start with you.
So I think a lot of that depends on trust with the community. And so oftentimes when water treatment programs roll out, especially for drinking water, it takes a while for community acceptance to come in. And so the technology may be there, but you still have to have community acceptance of that technology. And so there's a key step in the logistics of actually building trust and communicating with the local communities and having stakeholder engagement. So Thushara is a very good moderator and sent us the questions in advance. And I looked at this question and my immediate response was we have this huge resource, right? We have all this water. If we can treat it, then we can extend the life of fresh water. The issue with this is that it's an extension, and those resources are not being recharged. So it's sort of like carbon capture and underground storage, where it's a bridge, right? And maybe part of it's a permanent solution, but we will need to use the terminology from yesterday from one of the speakers, evolve away from using that technology, okay, over probably the series of decades.
Thanks, Alex. So, Runway, anything you'd add?
Sure. I would like to say we are never a state that's shortage of water. We have water, though not fresh water. We have those brackish water just under our ground. We have those produced water, as our colleague Gendry mentioned, how many of them is being produced every day. We are never a state of with less water. The only thing we need is that we need the people, we need the workforce to treat those water, to convey our scientific perspective to those people who are not figuring out this is a water that can be used to overcome our water shortage. So we are fighting for that now, and we'll keep fighting for that. We are in the progress to turn New Mexico into a water-rich state. Thank you.
So Runway was brought up a very good point about workforce development for water treatment. The water workforce, from water operators and wastewater operators all the way up to PhD level researchers, is currently hurting. So that in the energy community, the salaries are high. We may have brain drain, but the salaries are high. The water community, because it's governed through utilities and the government, the salaries tend to be lower despite the high community value. And so currently, the water and wastewater operator associations are trying to build apprenticeship programs. We're running short of water well drillers, and then consulting companies for water resources and environmental remediation are having trouble recruiting the workforce. And so the same issues exist on the energy side that on the water side, but it's a little bit more exacerbated because of for one reason, lack of slightly lower salaries, right?
Great point, Alex. So we'd certainly need the technologies there, but also need that community engagement and workforce development. So Prashant and Jinja, you both talked a little bit about, the different energy treatment technologies that you're working on maturing. Could you comment a little bit on what is the relative readiness level of these technologies, and how are you engaging with local communities or training that next generation as part of your research?
Yeah, so right now we are at TRL4 level. And most of the produced water technology which you look at, they might be in TRL5-ish. And they are looking to go towards with pilot scale, they might be at 6. Like that technology might be at 6, I'd say. But yeah, to jump from 6 to something like 8, where it gets commercial, we need a lot of data points and a lot of testing. And in addition, one thing I would like to mention is when we are talking about produced water treatment, depends on even for a particular location. Like if you want to do for produced water treatment in Permian, at a particular location, the water quality will change throughout the year. So that really affects the performance. The salt concentration throughout the year might vary, and over the years it will vary for sure. The organic concentration will vary for sure, and that really affects the performance of the system. So if you had designed the system for say 1 million gallons per day, and you might be getting after 3 years, it would be only 50% of it. So those things really need to be addressed, and it needs, because it's not like seawater, because seawater concentration is always going to be constant, constant.
So when we talk about the technology, especially the produced water treatment technology, so I want to share a story. So when we tour some visitors in the lab, and when I show, okay, so this is original produced water, this is treated produced water, and when I tell them, okay, so we can reduce the total dissolved solids by 99.999%, and this water is super clean, so we can use this water to do a lot of beneficial purpose. So will ask me, can you drink it? Can you drink it? Yeah.
Right now.
So from the EPA standard, I'm confident I can drink it. Yeah. Because it satisfies, all the EPA drinking water standard. But the problem is the source water is produced water. Yeah. So when we talk about the produced water, so just like Dolly mentioned, there's still a lot of things we don't know. So we can detect most of the component in the water before and after treatment. But how about maybe there's some component we still don't know? So right now, I think that is the biggest challenge for produced water treatment. Yeah. So in my opinion, actually, the collaboration. Yeah. I know New Mexico State University, they have a great group working on the produced water characterization. Yeah. Especially if there's something we don't know. Yeah. So they use a lot of advanced technology, to test. So what kind of unknown component, contaminant in the water? So before, we discuss, okay, so if this technology is TRL 6 or 7, so I think it's very important for us to understand, so what is exactly in the treated water? Yeah, so that's my point. And in terms of the workforce development, so actually, so we have used the same technology. So for example, we work closely with the Navajo Nation, so the Navajo Technical University. So we are trying to use the process to treat the groundwater. So I just mentioned, we are trying to deal with the uranium, arsenic. If we know what kind of contaminant already in the water, such as PFAS, if we know that already, so we can very confident we use our membrane process, to do the water treatment. And if we can, if we can have enough water treatment capacity, we can also reduce the cost. So it's determined by the source water. So if the source water actually, so we know what is in the water, it's easy for us to reuse it. But if there's something we still don't know, and that's the most challenging part.
That makes sense. Thank you. All right, switching to audience. Do y'all have any questions for our panel?
So kind of back to the point of this is all cleaning up, so to speak, from an actual restorative moment to rebuild water tables for the state. What, if any, work are you guys doing in terms of regenerative agriculture or things that actually restore water table and bring the water back out of the sky, quit the runoff, those kinds of things versus actually cleaning up the muck?
There is one ongoing project we have. As we mentioned, we know this is the way that we want to accelerate this battle with the water shortage, but we want to slow down. So in one of the ongoing project we have is that we assume we are going to have used those treated produced water as irrigation water in agricultural field, but we didn't do any field testing yet. Everything right now happen is only in the lab scale. So we want to first test how far those potential contaminants going to travel. So I'm not afraid to tell everybody that even though we have those treatment for the produced water, we still have something there. We have benzene, we have toluene after preliminary treatment of a produced water. And those potential environmental contaminants, they could accumulate in the subsurface, or because they are volatile, they probably go to the atmosphere. Although they are at a minor levels, we don't think they will pose any acute toxicity to the people or to the environment surrounding, but we want to confirm. We want to know if we're going to really use this treated water in the agriculture field. So how far it will travel? Are they going to accumulate? Are they going to emission? If there are any contaminants being caused by this land application, what will be our solution? There's will be one of the ongoing project right now. And the things we have there is that we try to simulate the real case. We collect the soil from the MSU Atisha agriculture fields, and then those soils being grown with a wheat in 2023 is a real agriculture soil, and we want to simulate those environmental contaminants potentially what will be their fate and transport in their real life application. Thanks.
So there are a number of efforts around the state that are focused on increasing water supply and protecting the resilience of water supply. So we have some efforts here at New Mexico Tech. I am mostly, as an old mentor of mine at Sandia told me, I'm a pointy-headed person, right? So I worry about measuring changes in storage, and then I work with folks, economists or water resources specialists to understand, or folks like at the Bureau, right? Who worry more about the community outreach and quantifying resources and talking with communities about use, right? I believe there's a center or two at UNM focused on water resilience. And New Mexico Tech is involved with that. I'm not sure about NMSU, and a good chunk of that is focused on upland protection, right, to forest fire and forest fire response. And so our entire surface water supply is dependent on snowpack. And so if we're gonna, and then the groundwater system, this is one of these examples of being in a small state with a lot of very smart people. New Mexico was one of the first states to actually have conjunctive management of groundwater and surface water in the country. So we've understood for almost 100 years that the surface water system is connected to the groundwater system. So ultimately our groundwater supply is connected to the snowpack. That means that we need to manage the upland forests. We need to protect them from forest fires. And so there's a number of efforts across the state focused on forest management for recovery and protection from forest fire. In terms of agriculture use, again, NMSU has programs focused on irrigation. I'm working on, understanding how different cropping, types change in the high plains for more water efficient and eventually dry land agricultural practices, and the feedbacks that happens on the soils that control sort of the efficiency of irrigation. And so there are a number of efforts across the state. I think most of the panel is focused on water treatment, right, of produced and brackish waters. So I would be happy to talk more about this. So.
Yeah, and then my question is, Prashant, you said 60% produced water is injected back. What happens to the other 40%? Is it utilized, or is there some evaporation in there, or rough number?
Yeah, so currently they are reusing it for drilling itself. So they mix it with
so that 40 is utilized. Yeah.
So initially the water to oil ratio used to be in range of 10.
Yeah.
But now because of this reuse, they have brought down close to 4.
Yeah. Yeah, because I was just looking as running the numbers, and it just shows the total usage, and they're always like so far behind on total New Mexico water usage. It's 2015, I believe, is the most recent. But It's very small now, industrial use. And then my question for Dr. Lee, just because it's good to have another fellow Aggie in the audience. And I think you, Dr. Reinhardt, talked about a little bit. 75% of the water in New Mexico is used for agriculture, and the last number, 97% of that is flood irrigation. Is there, is there hope in that area? And then because it seems like that's always in New Mexico, the acequias and the irrigators are always the ones with no pressure to use water in a more efficient way.
There
No
are
offense, farmers.
I would like to say I won't directly respond, but I will respond with a fun observation we have. So for one type of a sample of thermal treated produced water we have in the lab, we sampled it in May. And then at that time, we have detected the benzene toluene, as we mentioned, at like a 0 point something ppm level. But after, I would say 4 months, like when we try to start those feed and transport starting in the lab, we try to recharacterize those sampled water, and we found those things are gone. So it's just bring our a thought that what if we just collect those produced water instead of doing advanced treatment, we just let it residence. Let it stay there, because most of those organic matter, since it's come from the oil and gas industry, is volatile or semi-volatile. It's any way, any technology we can accelerate those emissions from the water phase to the atmosphere phase. And then instead of treating those things in the water, we collecting those things once it emitted out and just burn them. Something like that. I mean, that's just my thought. But I would like to share that this type of a possibility of using those produced water, treated produced water, is our ultimate goal. We try to pursue that way, but before we can confirm it is safe for everybody, it's safe for the environment, we will put a question mark and we'll keep our efforts in that area. Thank you.
So one other thing I would just add to that is building on Secretary Kinney's comment is when we look at things with a single objective, like this is the percentage of water we're using for agriculture, it's easy to overlook that agriculture plays a different role in our society as well, right? There are livelihoods that are reliant on agriculture, multiple cultures that have been on this land for various reasons. And we're already seeing a shift with water scarcity causing families to consolidate land or to walk away from their properties. And I wonder if there would be more of an opportunity to think through water and the role it plays in this larger energy ecosystem to develop more innovative economic and policy solutions that enable us to be carbon mindful, respecting our water resources at the same time, but recognizing that there's a deeper culture, a deeper history here than looking at any one of these resources in isolation. So completely get it. It's a complicated question, but as we're hearing right over the last day and a half here at the consortium, there's a different dimension to every single problem we're talking about. There's security, there's natural resources that are changing, their resilience, their sustainability considerations. And we're just very grateful that you all are willing to hear about water today in the context of energy. So with that, thank you all for sticking it out through the break. Encourage you to
I just have a quick comment, or a plea rather, going back to characterization, is that I hope when you all do characterization that you will consider doing a full suite of elemental composition of these waters. We really need to know what the rare earths are, what the copper, what the metals, what the other critical minerals are in these waters, because then we may actually be able to turn around and say, hey, there's a potential use for that. So therefore it will help in the economic context of all this. So, but if you don't do that characterization and get that, then we don't know what's there.